Hi, good evening, everyone. Welcome to JEE Amrita Crash Course. How are you all? Hope everything is fine. And today is chemistry class, and we'll be discussing very few exciting questions. Okay, so shall we start now, or should we wait for 1 or 2 minutes? Okay, so let us start with this question then. Okay, so this question is about, see, isotonic. Do you know what is isotonic means? Anybody knows what is isotonic? Isotonic means, see, let me define this. No, what is isotonic? Isotonic means same osmotic pressure. Okay, same osmotic pressure. Okay, so this is very useful concept. Okay, even in biochemical reactions also. Very simple example we can take. No, if the person is too weak, no, so what doctors will suggest is saline injection, right? They'll inject saline. So that saline, NaCl, the saline means basically aqueous sodium chloride solution and some other ions, right? So that pressure must be isotonic with blood pressure. Okay, so then only it can be injected successfully. Otherwise you might have observed, no, that there is change in pressure. So what will happen? Sometimes blood goes backward to the saline. Okay, or swelling will occur, right? If there is properly not concentrated, no, so these things will happen. But if it is isotonic, the saline pressure and blood pressure are equal, then that can be safely injected. Okay, so that means osmotic pressure must be same. Okay, so here what is given, 5% solution of cane sugar is isotonic with 1% solution of X. So what is the molecular weight? So whenever percentage is given, no, so you must take this as weight by volume percentage. Okay, so this by default. Okay, they may not mention this is weight by volume, but by default for osmotic pressure, no, for osmotic pressure, I'll write it, percentage given in osmotic pressure means that is W by V percentage. Clear? So this must be W by V percent. So how we use this? What is osmotic pressure formula? Pi is equal to I into C into R into T. Okay, this C means concentration, I means water factor, R means universal gas constant, T means temperature. Here very simple, by looking at this question, cane sugar, no, cane sugar I is equal to 1, and this substance is mentioned, nothing about their ionization, ions, right? Here also I is equal to 1, right? So I say temperature is not mentioned, that means temperature kept constant, right? So this R also constant. So osmotic pressure is same means what exactly we are equalizing here? So pi 1 is equal to pi 2. So that means C1 is equal to C2. Basically concentration must be same. Concentration is molarity. How do we relate molarity to weight by volume percent? So we should know this formula. I'll tell you. I'll explain this formula. Molarity is equal to weight by volume percent into 10 by molecular mass. Okay, weight by volume percentage into molar mass. So this is the formula. Okay, so we can directly use this, correct? So how we'll use this? C1, let us say this is cane sugar solution. Okay, so 5 into 10 by molecular mass of cane sugar, it is given, right? Molecular weight is 342. So that is equal to, this is 1% into 10 by m. We don't know molecular weight, right? So you can directly calculate this now. Okay, so how much? What is the correct answer? Can you tell me quickly now? What is the correct answer? Right. So 342 by 5, correct? 342 by 5. Exactly, 68.4. So this is how we should do it, right? M is equal to 342 by 5. That is 68.4. That is molecular weight of unknown solution. So basically, osmotic pressure. Keep in mind, what is isotonic? Isotonic means same osmotic pressure. Okay, fine. Next, look at this question. There are 4 options given and each solution molality is also given. Concentration is given as 0.1 molality. Which one will exhibit largest freezing point depression? How do we do this? So what is the formula for depression freezing point? Delta TF is equal to I into KF into M. KF means this is a constant. Okay. M means molality. I means water factor. Water factor is based on ions. How many ions are released? Okay. So here, water factor, I can take it as N. Number of ions produced per 1 mole. But sir, how do we find out I value here? KF value is fixed. Okay. We'll cross this. Okay, this is fixed value for each and every solution, right? All our aqueous solution means what? Solvent is water, right? Solvent is water, so KF is same. We just need to compare where largest freezing point depression means delta TF is highest in which of the following solution. So delta TF proportional to, we are just comparing, we are not calculating. So don't worry about KF. And molality also, because molality is, they are saying same, right? So molality is 0.1. This is same. Okay. So delta TF directly proportional to I value. But I is equal to N because degree of dissociation is not given. Assume 100% dissociation. But how do we find out I? Okay, so that means KCl 100% dissociation, K plus plus Cl minus. How many ions are there? Number of ions are 2, K plus and Cl minus. Now for glucose, C6H12O6, no? How many ions? It is not dissociated. Don't write carbon plus hydrogen plus O minus. No? So that's not correct. So what you should do, this doesn't undergo electrolysis. Means there is no dissociation. So it can't conduct electricity. Glucose solution will never conduct electricity because there are no free ions, right? So it cannot produce ions. So I is equal to 1 only. There is one molecule, that's it. Okay. So like that, can you tell me Al2SO4 3? How many ions are there? 2Al plus 3 plus 3SO4 minus 2. How many ions are there? 2 plus 3. So I is equal to 5 here. Okay. K2SO4. How many ions are there? 2K plus plus SO4 minus 2. How many ions are there? I is equal to 3. So where I is maximum? I is maximum here. I is equal to 5. So if I is maximum, so delta TF is maximum. Clear? So what is the correct option now? You got the clarity, right? Largest freezing point. Largest freezing point depression. Where is the difference? No? C. Option C. Okay, right? So understood. We did two colligative properties. One is osmotic pressure, other one is depression and freezing point. So I hope everybody understood this question explanation. So we'll move on to the next question now. See this. 0.002 molar aqueous solution of ionic compound, okay, freezes at this temperature. How many number of moles of ions which 1 mole of ionic compound produces on being dissolved in water? Just read the question. What you understood here? So again, same formula, right? I hope you can solve it very easily. I into Kf into M. So what is provided here? Delta TF is provided, right? Look at this. What is given if you write it, no? So what is given information here? Molality is given. So this is molality, right? So 0.002. So what is delta TF? Delta TF is also given, right? This is freezing point, but delta TF means change from 0. This aqueous solution, again solvent is water. What is water freezing point? 0 degrees Celsius. Okay, but this compound freezes at this minus 0.00732. So this will be the depression, the change will be 0.00732. Okay, number of moles of ions we need to find per mole. So just substitute this. We need to find I value. Kf is also given. Kf should be equal to 1.86. Don't worry about minus sign. You cancel this. Okay. This has to be 1.86. Kf can't be minus. Okay. So this will be 0.00732 is equal to I into 1.86. Molality is 0.002. Can you solve this and tell me what is I value? What is I value? Everyone is getting same? Just check calculation. Everybody should get same answer, no? Is it multiple 186 and 732? Yes, right? I think so. Almost 4 times, no? Almost 4 times you can take. 186, 732, almost 4 times. Nearly 4 times. So this should be equal to 2. Okay? Just solve this. We'll get this. So 186, 732 by 186, I'm taking nearly 4. Okay. Understood? So number of ions they are asking. So number of ions are how many here? 4, right? Okay. 2, sorry. I equal to 2. This value is 4. So we'll move on to the next question. Yes. Now this is from different chapter. Let us see. Very, very important model it is. Standard electrode potentials. Okay, standard electrode potentials of these metals are given: aluminum, silver, potassium, chromium. What is the correct decreasing order of reducing power of these metals? So remember one thing, very, very important. So this is simply called as standard electrode potential. So look at this, no, what is happening here. If I write this represented, this convention, no, this is represented A naught AL plus 3 AL, right? Or E naught AG plus 2 AG. So if you see this, no, this is basically reduction. Standard electrode potential means this always reduction. Okay, reduction potentials are given. Okay, what is given here? Reduction potential. But if SRP value, this is simply called, standard reduction potential is SRP. SRP is more value, including sign, very important. This including sign convention. If it is minus, it should be less minus or more positive side. Okay, SRP more, then which nature will be more? If SRP is more, what reaction is taking place here? So I'm writing a general reaction. Mn plus n electron gives M. This is aqueous and this is solid. So E naught is positive. So that means this reaction, forward reaction, is spontaneous. So that is the meaning. E naught is positive means this is spontaneous reaction. Spontaneous reaction, forward reaction. So that means it is gaining electrons, right? It is taking electrons. So what is the nature? Is it reducing nature, oxidizing nature? Tell me. M, if you see M oxidation number, what is happening? N plus to 0. M is reduced itself. M is reduced. N can't be negative here, okay? N is reduced. N plus to 0. So this is good oxidizing agent. If SRP is more, what you can infer from this? It is very good oxidizing. Oxidizing nature increases. If you remember this, reducing nature means opposite. No? If SRP is least, including sign. That means what you can write is more negative. SRP is least means more negative side, least value. Okay, reducing nature is more. Okay, reducing nature is more. So you can remember any of this. So either oxidizing nature or reducing nature. If you remember reducing nature, oxidizing nature is just opposite. Okay, now tell me, you can compare these values, right? So what we can take here, this one, right? We can take this one. SR, reducing nature, they are asking. Reducing power, reducing nature, reducing power, right? So reducing power means SRP should be least. So values are given here. Okay, AL minus 1.66, AG plus 0.8, more negative, strong reducing agent. Which one is more negative? Oh, clearly minus 2.93, potassium, right? Potassium is more negative. So potassium is more negative, potassium should be highest. So you can remove, eliminate, ignore these options, right? These options are not correct. Either this or this, B or C. Okay, so you can see either B or C. But in B or C, silver is positive, right? All are negative. Silver should be least. If it is more negative, good reducing agent. Positive side, it is weak reducing agent. Understood? Okay. It's a very important concept from electrochemistry. So option B is the right answer. I hope everybody understood. So this point is very important. These two relations, comparisons. SRP values means including sign we have to take. If it is more, including sign means more positive side, oxidizing nature is more negative side, reducing nature is more. Okay. Next question to you. See this one. Now, very interesting question here. E naught values are given. Plus 2 to iron minus 0.441 plus 3 to plus 2 is given. So what is the standard EMF for this reaction? How do we find this? Okay, so what is happening in this reaction? Let us see this. Fe plus 2 Fe plus 3 gives 3 Fe plus 2. We need EMF for this reaction. EMF, standard EMF. What we know here? We know that Fe plus 2 electrons, no? So that is iron. See, this is given. I'm writing that reaction. This is minus 0.441. Okay. Next, Fe plus 3 plus electrons. No, this is giving Fe plus 2. So this is how much? 0.771. Okay. So now tell me, okay, for this reaction. Okay, first let us decide no what is cathode, what is anode. That's a very important, because two reactions are taking place here, right? So 0 to plus 2, 0 to plus 2. So this is means oxidation takes place. These are very fundamentals, no? Oxidation means anode. Okay, anode, cathode, I'll tell you. Okay, this way we write, this is convention. Anode means oxidation. Okay, cathode means reduction. Okay, so what we should do, E naught cell, very simple, E naught cathode minus E naught anode. Okay, E naught cell, if you construct a cell, what you should do, E naught cathode minus E naught anode. Just take SRP values only, don't change sign. Do not change any minus plus here. Directly with sign you can take it and subtract cathode minus anode. Which one is cathode here? 0 to plus 2. So this is anode, right? This is anode. Okay, now this one is cathode. Both are reduction potential. So this is SRP. See how I'm writing SRP? Fe plus 2 to iron. This is Fe plus 3 to Fe plus 2. Both are SRP values. Okay, we'll mention here. So these both are SRP values. So if there is SRP value, how we should do this? E naught cell is equal to cathode. Cathode is how much? 0.771 minus, and don't change the sign, no? Minus 0.441, because both are SRP, right? So this must be plus 0.7 plus 0.4, 1.2 approximately, right? So this should be option D. Any doubt here? Okay, so very simple. In the reaction, just identify oxidation and also reduction. Okay, so you will get option D. So this formula we should know. We should aware of this one. Okay, shall we move on to the next question then? Right, everybody got the answer, right? Okay, so this question now, is it visible now for everybody? If there is any audio issue, video issue, no, so please let us know immediately. Okay, fine. This is electrochemical cell. In electrochemical cell, no, always write left side anode. So left side, this is anode. Okay, right side cathode. Right side cathode. EMF of cell is E1. When the concentration is changed to 1 molar, okay, and that of copper sulfate changed to 0.01 molar, EMF changed to E2. Okay, E1, E2 we have to compare. Okay, E1, E2 we have to compare. So what is E1? So this is not standard condition, right? See, this is not standard cell. 0.01 1 molar. Sir, what is standard? Standard conditions in electrochemistry is 1 molar concentration, 1 atm pressure. So if it is a gas, no, 1 atm pressure we must take. If it is solution, we must take concentration. Okay, so we use Nernst equation. What is Nernst equation here? E is equal to E naught is standard minus 0.059 by N log Q. But what is Q, sir, here? Q is reaction quotient. Okay, for reaction quotient we must write cell reaction. Okay, so what is cell reaction here? Right left side anode oxidation. I'm writing oxidation here. Okay, oxidation here. Zn plus 2 electrons. Okay, and right side reduction, Cu plus 2 electrons. This is reduction, and this will be Zn plus Cu plus 2 gives Zn plus 2 plus Cu. So our reaction quotient, no, this Zn is solid, copper is solid. So this reaction quotient we can take Zn plus 2 by copper plus 2. Only aqueous solutions and gases must be taken while writing reaction quotient. So we'll write quickly E1 here. In E1, copper sulfate, right side means, look at Q, denominator is 1, okay, but numerator is 10 power minus 2, that is E1. Okay, so let us try this. E is equal to E naught, E1, I'm writing E naught minus, 1 second. Okay, fine. Where are we? This, right? So E1 is equal to E naught minus 0.059. How many electrons are involved here? 2 electrons, right? So there are 2 electrons. Okay, so 2 electrons and log Q, reaction quotient, no, 10 power minus 2 by 1. Fine. So this is how much E1 is equal to E naught. You bring this side, E naught plus 0.059. Because 2 get cancelled, right? Log 10 is 1. Same way, E2 is equal to E naught minus 0.059 by 2, but they reversed it, right? So it's a just reverse. Numerator is 1, but denominator is 10 power minus 2. Numerator is 1, denominator is 10 power minus 2. Okay, 10 power 2 it is. Okay, so this will be E2 is equal to E naught minus 0.059. So just compare these two now. So which one is greater? E naught plus something, right? Obviously E1 is greater. Okay, E1 is greater, E2 is less. Okay, E1 is less, sorry, E1 is more. E naught plus this, E1 is greater than E2. So option B. Any doubts here? No, right? Look at this. Okay. No doubts. Okay, fine. So we'll move on to the next question now. See, reduction of silver ions with copper metal have standard potential 0.46. What is the standard Gibbs energy? How do we do this? It is direct substitution, okay? But it's a very, very important model it is. Always for any cell, you can find out delta G naught is equal to minus NF E naught. Okay, delta G naught is equal to minus NF E naught. So this is just a calculation. You can do it later also. Okay, minus, but how many electrons are involved? That is the only important thing. N calculation is important, rest is just a calculation. So I'll tell you how do we find out N. So look at the first information, reduction of silver ions with copper metal. Okay, copper metal is reducing silver ions. Silver valency is how much? Can you tell me what is silver valency? +1 or +2? Silver oxidation number, no? It is +1 exactly, no? So what you should write is Cu plus Ag plus, and this is Cu plus 2, because copper is reducing silver ions, so copper must go undergo oxidation, right? Plus silver. Now look at this, charge is not balanced, no? Charge is not balanced. Okay, so how do we balance charge here? Right side. Acha, how to find valence in exam? See dear, we are not finding valency. Basically, there are no formulas. No, we should know while revising inorganic. Okay, like transition elements. No? Copper can have +2 oxidation number, +1. Silver can have one oxidation number only, +1. Scandium can have +3. Iron can have +2 and +3. So this you will get to know in the respective blocks. Like D block, you will get to know about these elements. In P block, you will get to know about like lead, tin elements. So group, when you revise group wise, you will get to know what are those general oxidation numbers. Okay. Okay, fine. So next, how we should balance the charge also. So how do we balance charge? You multiply with 2. So charge is balanced. Sir, how charge is balanced? See, +2 charge here, 2 into +1. And this +2. Charge is balanced, right? Now, how many electrons are there? So it is equal to charge. No? So N must be equal to 2. So rest is very simple. Delta G naught is equal to -2 into 96500 into E naught. So that is plus 0.46 SI units, right? Because coulomb into volt, so that you will get joules. You can match the option later, but this way, N calculation is only important thing. How do we find out N? Based on the charge. Okay, fine. So what is the answer for this now? Can anybody tell me? Calculate and tell me this. So 2 into 96500 into 0.46, no? 89,000 means 89 kilojoules. So it must be minus, right? Kilojoules. So option A. You will get option A. Okay, right? Okay, done. Next. Achha, this question now. Limiting molar conductance. What is limiting means? Limiting means infinite dilution. This is the maximum molar conductivity. Always conductivity increases upon dilution, no doubt. Okay, limiting means maximum. You can't get more than this, no? So you can write this limiting. Here representation is given. Look at this. It is, I'll zoom it. Okay, so this is 0, or sometimes what we write is infinite also. 0 means what? 0 concentration. Concentration is 0 means infinite dilution. Infinite dilution. Okay, so H2SO4 is given, K2SO4 is given, potassium acetate is given. Okay, so what they're asking, acetic acid in the same units. Just make sure units are same. Yes, units are same units. What you have to do first, what are the ions in acetic acid? Just look at this. What are the ions? We write dissociation, minus plus H plus. Okay, fine. What you have to do is, we need these ions. Okay, because acetate acetic acid, if you write here, it is taken as 0 concentration. If you write infinite also, it's of same meaning, but infinite dilution. So acetic acid is equal to what? Acetic acid is equal to ion, acetate ion, okay, plus lambda m infinite H plus. Lambda m means molar conductance. So there is a simple trick. Wherever common ions are there, you add. Wherever common ions are there, you have to add that particular electrolyte. You have these three electrolytes. To calculate molar conductance of acetic acid, we have three electrolytes. So what you have to do? Common ions add. Without common ion, you subtract. Very simple way. This trick you can use. Common ions are there, you add. Without common ion, you subtract this. So then you will get, no, sir, common ion with what? Common ion with the given thing, no, acetic acid, acetate ion. Is this have common ion? Yes, CH3 COO minus is common ion. Okay, and what about this H2SO4? Yes, common ion. Correct, no? This has common ion. So we should add these two. Okay, so we should add these two. See how I'm adding this. Lambda m, okay, lambda m in 0 sodium potassium acetate. Common ion is present. See, I'm highlighting this. No, this is our common ion. Okay, K plus is not common. Leave it. At least one common ion. Okay, acetate is there. Yes, plus lambda m 0. Where is the other common ion? H2SO4. No? H2SO4. We add this. But see, okay, as it is molar conductance, we are to subtract without common ion. Without common ion is this, right? Without common ion is this. Okay, so we'll subtract this. So lambda m 0 K2SO4. So what is the correct answer now? Tell me. This must be 2 times, but K is not balancing, no? K2SO4. K is not balanced. So what you have to do is, this is 2 times. Okay, and this is 1 time. So look at this. This has to be 2 Z. You know? This is Z unit is given, plus H2SO4. H2SO4 is how much? X. X. But this is minus Y. So correct option should be A. X minus Y plus 2Z. Option A. Got it? Common ions you have to add. Without common ion, you will subtract this. Then you will get respective, okay, molar conductance. I hope no doubts, right? Fine. Moving on to the next question. Right. Very important model here. Types of conductance is covered in this question. Specific conductance of a KCl solution is given. Look at the units. With these units, you should get clarity. What is given here? K is given. Okay, what is given? K value is given 0.012 ohm inverse centimeter inverse. Okay, resistance of a solution, cell containing solution at the same temperature, resistance is given 55. Look at the unit too. What is cell constant? Cell constant basically L by A is how much? And the formula for this is, what is the formula? Specific conductance is equal to 1 by R into L by A. So it is direct substitution now. Okay, L by A is equal to K into R. Very simple. And by looking at the units also, you can clearly get idea, right? K into R. So we have K value, we have R value. So this gets cancelled per centimeter. How much it is? 0.012 into 5. No? How much the value? 0.66, right? 1256, right? So it should be in 6, no? 66. Okay, so that's a very simple question. Okay, fine. Yes, exactly. Next question. Look at this one. These questions from Faraday's laws. Okay, Faraday is a brilliant scientist. You know, Michael Faraday, he worked in a bookstore, book binding store. Okay, but he has that scientific temperament, means he want to know more. He has more, was more curious to learn new concepts in science. So while working in book binding shop, no, he used to read many books. Okay, uh, he is the newspaper guy also. Okay, and he worked in book binding shop, and the most like brilliant scientist in physics and chemistry is Faraday, most hardworking. Okay, he used to listen the lectures from the university lectures as a vendor, book binding vendor, but in the same lecture hall, no, he gave lecture about Faraday's laws. He demonstrated, okay, how electricity is related to mass, to find out mass of metals. Okay, one of the most inspiring character in chemistry I liked most is Faraday's. So if you have some time, please read his story, okay, on Google, Michael Faraday. Okay, fine. So Faraday's laws: number of electrons delivered at the cathode during electrolysis by a current of 1 ampere in 60 seconds is how much? How do we do this? So they are given number of sorry, electrons they're asking. Okay, so what is given here? Let us write this. 1 ampere current is given. Okay, so and 60 seconds. Okay, so I think very simple, right? Number of electrons they are asking, and what we know about this, Q is equal to IT, I into T. So this will give us charge, right? Okay, so Q is equal to IT, and this is 60 coulombs. But what we know here, one electron charge is given, right? So 1.6 into 10 power minus 19 coulomb is one electron. But 60 coulomb is how many electron? That is what the question, right? Exactly. So 60 by 1.6 into 10 power minus 19. So what is the answer for this? Sixty by 1.6. How much? So exactly, right? This is the correct answer. 3.75. Okay, this is 37.5 into 10 power minus 19. So 3.75 into 10 power minus 20. Okay, so 10 power 20, 19 and 20. This not minus. Okay, so try this one also. This is a little bit tricky here. When 0.1 mole MnO4 2 minus is oxidized, quantity of electricity, how much electricity it requires? Okay, to oxidize MnO4 2 minus to MnO4 minus, means for this conversion, MnO4 2 minus to MnO4 minus, how many electrons? First let us find for mole. Per mole, how many electrons? How do we do this? Let us find out oxidation number. Left side Mn oxidation number is how much? What is the oxidation number of Mn left side? +6, right? Exactly, right? +6. Right side how much? Sir, how you calculated this? Very simple. X I have taken -2 into 4 is equal to -2. X is equal to +6. So here x plus -2. Oxygen is -2. We know this. It is oxide. So x is equal to +7. +6 to +7. So it is losing electron, right? It is losing one electron. So 1 mole you can take it as 1 Faraday. Very important. Okay. 1 ion, 1 electron. So 1 mole is oxidized. So 1 Faraday. 1 electron means 1 mole electron's charge is 1 Faraday. Okay. So there is one change, right? 1 mole electron's charge, it is equal to 1 Faraday. So 0.1 mole is how much? So 0.1 Faraday. Okay. But 1 Faraday is 96500 coulombs. Okay. So what is our answer now? Option. See, you have to know this. Okay. Before doing question, no, 1 Faraday means what? We should know this. 1 Faraday is equal to 96500 coulombs. 1 mole electron's charge is equal to 1 Faraday. 1 electron charge is equal to 1.6 into 10 power minus 19 coulombs. So this is what we should know before doing this question. No? Okay. 9650 coulombs. Right. Next question. Let's do question from kinetics. Sorry. Kinetics, there is an equation. Okay. Reaction is given. And rate means what here? Rate means speed of reaction. How do we measure speed of reaction? Change in concentration by time. Okay, change in concentration by time. So look at this, how I wrote this equation. -1/2. According to the equation, we should write whatever the coefficient we write in the denominator, because per mole. Okay, so rate has to be defined per mole. So 2 moles are there, per mole means by 2. D 1/2 I'll multiply. I'll write like this, 1/2 and minus D N2O5 by dt is equal to, reactant side we write minus, but product side we should write no plus, 1/4 plus D NO2 by dt. Okay, so that is equal to dO2 by dt. Okay, but see this, listen carefully now. They have, what they have given is in terms of rate constant, k dash, k double dash. What is the relationship between these two? Okay, in all equations, no, whatever they have given, N2O5 power 1, N2O5 power 1. So 1/1 you have to equalize and find the relation. Rate is equal to, I can write k into N2O5. Okay, so that is 1/2, and the same thing you can assume, I'll write it here. Rate is equal to some constant into N2O5. Now k dash, k double dash, what is the relation? The coefficients are there, right? So the coefficients are there. So what is the relation? Can you quickly check? Okay, right. So what is the answer here? K dash is equal to 2K. Okay. Are you sure? K dash is equal to, where is K? NO2. Okay. DO2. What about this? Option B, option C, 2 times. Now see this, no rate equalize to this. Okay. Don't forget the coefficients. They cannot be equal, right? Option B, everyone? Sure? Okay. So look at this, how we solve this. So I'll write like this, no? K into N2O5 is equal to 1 by 1, I'll write 1 by 2 minus dN2O5 by dt. But what they're asking, only this, right? So this is 2K. Okay. So this is 2K. 2K N2O5 is equal to minus dN2O5 by dt. Okay. Next, the same way what I can write is dNO2 by dt is equal to how much? I can write 4K. Okay. N2O5 is equal to plus dNO2 by dt. And for DO2, it is just K. K into N2O5 is equal to DO2 by dt. And just observe these three. That's it. You will get the answer. K dash is equal to 2K. Yes, no doubt. Okay. But K double dash is equal to K double dash is equal to K by 2. Is it right? Yes, no? So option B should be the answer, no? Option B. Option B. Exactly option B. All right. So see this coefficients. That's it. Okay. And look at this question now. X2 plus Y2 gives 2XY. Reaction mechanism is given. Okay, reaction mechanism is given. Fast, slow, fast. Means some of the steps, no, fast, and one of the steps is slow. Okay. When the slow step is given, from that only we'll find out rate of a reaction. So first thing what you have to do is rate is equal to K into concentration of X, concentration of Y2. Fine. But remember one thing, this is called no rate law. What is this? This is rate law. Rate law always must be in terms of previous question. 1 second. I'll show you the previous question. Okay. This is the previous question. Okay. You see this. Done? Okay. Right. See this rate law. When you write the rate law is basically relation between rate of a reaction and concentrations. Okay. So rate law must contain reactants. Okay. Or sometimes, no, very rare, even products or catalyst. Okay. What we have to make sure is there should not be intermediate. Okay. There should not be any intermediate in rate law. But see, look at this. This is what reactant. This is reactant. But what is this? This is intermediate, no? Sir, how do we know which one is intermediate? How do we know which one is intermediate here? See, look at this. Look at the reaction. We know, right? Reactants are X2 and Y2. Product is XY. Now, what is intermediate? Anything other than these two, no, that is intermediate. Anything which is formed in the reaction, X is intermediate. But rate law should not contain intermediate. So what we have to do, we have to replace that, no. So from this step, what I'll write is equilibrium is equal to x square by x2. I'll write this. Okay. So I'm writing a constant is equal to x square by x2. What is x from this now? From this expression, what is x? K equilibrium into x2 power 1 by 2. Power 1 by 2. So we'll substitute this x. We will substitute this x. Okay. R is equal to K. X place K equilibrium. Okay. And x2. Sir, why are we substituting? Because rate law must contain, I told you, right? So rate law must contain this. In every rate law, it has to be either reactants, products, or catalyst. Okay. So this is power 1 by 2 and y2. Y2 seems fine, right? Y2 is reactant. No need to remove reactant, but we have to remove, no, intermediate. So rate is equal to K equilibrium power 1 by 2, x2 power 1 by 2, y2 power 1. And K into K equilibrium, this is just a constant. This is just a constant. And what is order here? Overall order of reaction is you have to add powers. The sum of powers of concentration terms. This is our rate law. This is the final rate law. Okay. This is final rate law. In rate law, just look at the powers. So what are the powers here? 1 and 1 by 2. So 1 plus 1 by 2, this is 1.5. So 1.5 is order of reaction. So what is the correct option here? Option C. So look at this, how we have done. Always start with slow step. Achha, molecularity is very simple. Okay, how many molecules are involved in slow step? That's it. In slow step, how many molecules are involved here? 1 plus 1. There's 2 molecularity. But what is order here? Order means after writing rate law, what are the sum of powers? This is order. You got the clarity? Okay. Molecularity means just number of molecules. It can't be fraction, but order can be fraction. Order can be negative. Okay. Fine. So we are done with today's session. Okay, I hope everyone learned some new concepts today. Okay, so we'll come back, we'll discuss some more new concepts in the next class. And please don't forget to share your feedback. K is equal to x square by x. No. I should write, no, K equilibrium, products by reactants, right? So I have to write this x square by x2. I need to replace x only. So only focus on that x. Okay, Ramnathan. Okay, just focus on x because every rate law should contain either reactants or products or catalysts, not the intermediate. X is the intermediates. I'm replacing x. Thank you, everyone. Okay. Thank you. So we'll meet in the next session. Okay. Thank you. So we'll be posting this PDF also. You can have a look at it, the solved questions. Thank you. Sure. Okay, bye. Take care. Stay healthy. Stay safe. Bye. Sure. Okay. Bye.